Bangalore city, the usually bustling highway now stands still. A convoy of 5 trucks awaits the green signal to enter city limits. The city sleeps, unaware that this convoy carries the answer to the residents' everyday traffic problems. This is the state-of-the-art tunnel boring machine, or TBM, which is going to drill the underground sections of the Bangalore Metro. The 17-month process will drill a tunneling line stretching 4.8 kilometers from Majestic Station via Central College and Vedant Saudha to the cricket stadium, with the last section drilling from Majestic Station underpassing a railway track ending at the city railway station. BMRCL officials wanted to ensure that the disruptions caused by the building of these stations were minimal.
It's precisely the fact that it's in the middle of the city that we decided to go underground. There were certain sections where you cannot have elevated lines except at great destruction to the people on either side of the road. Apart from that, there is also a legacy to protect.
The contractor for the Bangalore Metro underground construction is the CEC SOMA CICI joint venture. While SOMA works on the construction of the 4 underground stations, the Continental Engineering Corporation and its subsidiary in India, CICI, works on the tunneling process. With years of international expertise in building tunnels, high-speed rail, bridges and highways, and after meeting success with the Delhi Metro construction, CEC now brings the TBM to the Garden City. The convoy is making good time, but it must reach Majestic Station before 6 AM to avoid the morning traffic. As the TBM had to be custom-made for Bangalore's geological conditions, a series of tests were carried out in manufacturer Hitachi Zosen's factory in Osaka, Japan. A visiting team of BMRCL and CEC engineers carried out the final inspection before the TBM was disassembled and shipped to Tamil Nadu, where it was loaded onto 28 trucks.
Hitachi was a wonderful experience, and as the head of this organization, I learnt a lot. My colleagues learnt a lot in organizational behavior and group dynamics.
The convoy, after traveling 7,500 long kilometers, finally stands at the Majestic Station at the break of dawn. There is excitement in the air. A shaft 28 meters long, 22 meters wide and 16 meters deep is ready for TBM parts to be lowered into. Assembling the parts is going to be no easy task. Months of preparation have led to this moment, and all the workers have been trained to handle equipment and to follow safety precautions. The first part to be lowered is the front body lower section, which is the foundation piece around which all the other units are bolted. Overseeing the assembly process is Project Manager Russell Brown.
The second part will lower down the shaft. That weighs approximately 56 tons, and that's called the drive module. This section needs to be turned over into a vertical position. And to do that, we use 2 cranes. One of them is a 350-ton duty crane. The second one is a 100-ton assist crane.
Here, communication poses a greater challenge, as interaction with the crane operators is only possible through hand signals and radio. The third module is the front body upper part, which is now fitted on top of the front lower body, wrapping around the cutter drive structure. Then, 10 cutter drive motors and the decompression chambers are fitted onto the driving module.
We often inject an air pressure up to approximately 30 psi. This pressure is equivalent to what you would put inside of your car tyre. If you took this car tyre and put it inside of the cutter chamber, it would actually go flat because of equalising in pressures.
On the 29th of April 2011, fighting with the Bangalore rains, the engineers lifted and lowered the cutter head. Post-cutter head positioning, the articulation section is bolted on, which allows the TBM body to be angled by degrees. The middle body rear side section equipped with the 16 thrust rams is then fitted into position. These are used when building segments or when pushing forward during excavation. Attached to this middle body is the slurry inlet and outlet pipe, which helps in carrying the drilled mud to a recycling plant on site. Here, coarse gravel and fine particles are removed, and the resultant slurry is then sent back to be used for tunneling. The final component is the rear body section with segment erector. This unit is fitted to lift and place the tunnel segment into the correct position before thrusting forward. These segments are manufactured in a plant in Pina Industrial Area, where over 100 construction workers help manufacture segments at a speed of 12 segments per day to meet the 21,120 segments requirement. With this, the TBM stands completed, weighing a total of 350 tons.
BMRCL is new to tunneling. Bangalore Metro is new to tunneling. Namma Metro is new to tunneling. CEC is not new to tunneling. And we are quite confident about the ability of CEC SOMA. CEC has got all the experts and they are willing to share. And that's the good thing about this partnership as it begins to flower.